Hi friends, this is examples 4 and 5 of the Unit 1 Day 4 notes. This is using the distance formula. We're going to be using it geometrically. Geometrically is with a shape, with a drawing, with a picture. So here, what I want to show is the idea behind this is that we want to make this into a right triangle. So I am going to construct a right triangle in example A. So I have P is 1, 2, Q is 5, 4. So what I'm going to do is I'm going to draw out here this dashed line until I get to where Q is, and then on Q I'm going to draw a dashed line going down. So these are line segments, not lines. Excuse me. So here what we have is we just created what are called the legs of the right triangle. This is a right triangle here. So we just made the legs. What I want to do is I want to count the space or the distance from point P to this point here. So if I count 1, 2, 3, 4, so this is 4. If I count up 1, 2 from here, so that's 2. So we're going to be using those values to then find the distance from P to Q. So I'm going to grab our Pythagorean theorem, that's from the previous page, and I'm going to write it in this order where we put c squared first. It'll help with making sense of where we're ending up with the problem. So c squared, c has to do with the hypotenuse value, so that's the distance between P to Q. So this is from P to Q. A squared is one of the legs. It doesn't matter which one you pick, you just pick one. B is the other one. So if I pick A to be 4, so this would be 4 squared, and then B then has to be 2. So B would be 2 squared. So again, bringing down c squared. So c squared is equal to, in my calculator I can do 4 squared, or 4 times 4, that gives me 16. And then 2 squared, 2 times 2 is 4, so that gives me 4. So I have 16 plus 4. If I add those two together, c squared equals 16 plus 4, that's 20. Now here's the problem. That's not what the value of c is. That's the value of what c squared is. So what I have to do is I have to algebraically undo what squaring is. So to undo a square, we use what's called a square root. So we're going to apply a square root to this problem. Whenever we apply a square root, we square root both sides, which is what you do to one side, you have to do the other side. And so if I do that, I get c is equal to the square root of 20. Now in this case, I may want to know like the actual value to buy. Maybe I'm buying something. I'm buying lumber, wood, sheet of metal. I'm constructing something. And the square root of 20 isn't a number that a lot of people conceptually can say, oh, well, I need this much. I need a square root of 20 of, meters of lumber. That's not a common thing. So what we do is we just round to the nearest hundredth. So in this case, if you type this in your calculator and you get the decimal approximation, you get 4.47. Now that's what c is. I want to find what the distance from P to Q. They happen to be, for this problem, the exact same thing because of how we set it up. So the distance of P to Q is 4.47. I don't know how far it is, so I'm just going to use the label units. So the distance is 4.47 units. We do the same with part B here, so I'm going to set it up. So I feel confident using the grid as guidelines here. Again, I'm going to count the value. So I go 1, 2, 3, 4. This is 5 units to the right, and then 2 units up. So setting it up similarly, so I'm going to have c squared is equal to a squared plus b squared. C squared is the length of my hypotenuse. A, I'm going to say in this case is 2, so that's 2 squared. And if A is 2, then B has to be 5, so B has to be 5 squared. So then what I have is 2 squared, which is 4, plus 5 squared, which is 25. 4 plus 25 is in fact 29. So then when I take the square root of both sides, I get c equal to the square root of 29. Again, this does not give us a terminating answer when we type this in our calculator. So if I was to approximate it, it would be approximately 5.39. So the distance of Q to R, in this case, Q to R, is 5.39 units. And then now S to T, so the distance from S to T. So I'm going to make my triangle, make my right triangle. And this works because it's a right triangle. If it was any other type of triangle that we're making, it wouldn't work. 1, 2, 3, 4, so this is 4 units, and then 1, 2, 3, 4, that's also 4 units. So c squared equals a squared plus b squared. It doesn't matter which one I pick for a or b, they happen to be the same as this one, so 4 squared plus 4 squared. And then 4 squared is 16, so you have 16 plus 16. And then if I add those two together, 16 plus 16 is 32. If I square root both sides, I get c equal to the square root of 32. And again, I can get the decimal approximation for this. It's about 5.66. So the distance from S to Q is 5.66 units. Now, example 5, using the distance formula, it wants us to find the distance from A to B and the distance from C to D. Then it wants us to tell us if those segments are congruent. So to find the distance for them first, from A to B, I can plot, do the grid, do it algebraically, or I can make a right triangle, which I will here. So if I count down, that's 2 units down, I count over 1, 2, 3, 4, 5. So my distance down is 2, and then over to the right is 5. So this leg length is 2, this leg length is 5. I'm going to go ahead and find from C to D. We're just going to see. So here I have, this is 2 here, and then I have 1, 2, 3, 4, 5. So that's 5. Now visually, I can see that these are both the same numbers, and even though they're not kind of oriented the same way, this tells me that in fact they are the same distance or length as one another. I can't just say that though, because it also wants us to find the distance from A to B and C to D, but because I can see that they are the same numbers, algebraically, they will produce the same results. So if I do c squared equals a squared plus b squared, so I'm going to sum up the length of the legs, you get c squared equals a in this case, I'm going to call it 2, so let's go 2 squared, and then b in this case is 5, so that's 5 squared. So what I have is c squared equals 4 plus 25, and 4 plus 25 is 29. If I take the square root of both sides, square root, I get c is equal to square root of 29. Now I know that's going to be the same for the other triangle as well. How do I know that? Well, because it has the same values. Remember, order doesn't matter. If I put 2 in the A spot, then 5 is in the B spot. Or the other way around, if 5 is in the A spot, 2 is in the B spot, and we get the same result. So what happens is we created 2 triangle units that are exactly the same. If I created these are exactly the same. So, excuse me. So I know that AB, the length of AB. Now, because I wrote it like this without the topper above or the dash above it, that means I'm talking about the length of AB. And the length of AB is equal to the square root of 29. The length of CD is also equal to the square root of 29. Because those are the same, then I can say that AB segment, so segment AB, is in fact congruent to segment CD. Notice the notation on this. I did not say that these were congruent, and I did not say that this was equal. That actually, in the real world, if you think about, like, this is a number or a value, and then this is the shape. You wouldn't say shapes are equal, you would say shapes are congruent. And you wouldn't say numbers are congruent, you would say numbers are equal. Hope this helps clear it up. If you have any questions, reach out to your instructor. Have a great day.